Hello, welcome to the CCNA preparation guide brought to you by Eduonics. We're still on chapter 4, the IP routing technologies. We're going to be looking at static versus dynamic routing, link state versus distance vector, next hop, IP routing table, passive interfaces and how they work, administrative distance, which we've already covered really, split horizon, and metrics. So static versus dynamic. We'll look at some of the benefits of both of them really. Routing tables can contain directly connected, manually configured static routes, and routers learn dynamically using a routing protocol of some kind. Network professionals must understand when to use a static or dynamic route, not just their preference, but what's going to be appropriate for every project. And we're going to have a look and compare static routing and some dynamic routing. So before I look at the benefits of dynamic routing, you need to consider the reasons why people use static routing. Dynamic routing certainly has several advantages over static routing. However, static routing is still used in networks today. Networks typically use a combination of both static and dynamic routing, to be honest. Static routes have several primary uses, which include providing ease of routing, table maintenance in smaller networks that aren't expected to grow very much. Routing to and from a stub network, which is a network with only one default route out and no knowledge of any other remote networks. Accessing a single default route, which is used to represent a path to any network that doesn't have a more specific match with another route, in the routing table. Static routing is quite easy to implement in a smaller network. Static routes stay the same, which makes them fairly easy to troubleshoot. And static routes don't send update messages, and therefore don't require very much network overhead either. So the disadvantages of using static routes would include they're not that easy to implement in larger networks. Managing the static configs can become very time consuming and a full-time job. It requires quite a lot of back-end systems to be able to manage the upkeep of the configs separately from the routers, as in keeping them offline. And if links fail, static routes don't reroute traffic, so you don't have any redundancy. If you had a routing protocol in place, that would all be taken care of. You have to rely on configuration of devices on both ends to be manual, accurate, and to have somebody there 24/7 looking for link failures, or have something there that would report a link failure so you can get in and change the route manually yourself. So here router 2 is connected to other networks and the internet. It's also the only way out. If it just uses a default static router to reach any other network that you don't know about, router 1 has two networks that I need to know about, so I just use two static routes to reach both of those networks. So the advantage is that it's easy to implement in a smaller network. It's very secure and no advertisements are sent, unlike a dynamic routing protocol, which I often send in plain text. It's very predictable, as the route to the destination is always the same and never changes. No routing algorithms or update mechanisms are required, therefore extra resources such as CPU and memory aren't required either. The disadvantages of a static route is that they're suitable for simple topologies for special purposes such as a default static route. Configuration complexity increases dramatically as the network grows, and managing static configurations in large networks can become time consuming. If a link was to fail, a static route can't reroute traffic, therefore a manual intervention is required to reroute the traffic, which again is very time consuming and not very effective when it comes to SLAs either. So dynamic routing protocols help the network admins manage the time consuming and exacting process of configuring and maintaining static routes. So imagine the maintenance of the static routing configurations for these routers here. It will be impossible. You've got 7 routers all interconnected together with different routes and no dynamic routing protocol there to link them all together, which basically means, for these two to communicate to each other, if one link was to fail, you need to reconfigure all 3 to reroute the traffic. It's impossible, really. It's not impossible, but it's very difficult. And then what if a company grew It now has 4 regions that are exactly the same and has 28 routers to manage. What happens if a link goes down, and how do you ensure that redundant paths are available? Well, you can't in that kind of scenario, but you can with some other kind of routing protocol. So the advantage of a dynamic routing protocol is that it's suitable on all topologies where multiple routers are required. It's generally independent of the network size and automatically adopts topology to reroute traffic if possible. The disadvantages are it can be more complex to initially implement, not just from an understanding point of view, but from when it comes to actually getting the config on the routers and tweaking things to get things working. And also proving failover as well, because you have to test failover if you're doing a dynamic routing protocol. It's less secure due to the broadcast and multicast routing updates. Additional config settings such as passive interfaces and routing protocol authentication are required to increase the security, and the route depends on the current topology. It requires additional resources such as CPU, memory, and link bandwidth, but that's usually okay because everything's relative. I mean, these kind of networks that need dynamic routing, hopefully the network admins wouldn't have skimped on price, therefore they would have a decent amount of budget and quite a decent amount of resource behind them to cope with the routing protocols. It would be stupid to have a massive amount of routing going on something like a Cisco 870 or something like that. You need a bigger kind of not I'd say a core switch, but at least a switch that's a couple of layers down to cope with that kind of thing. And if it's going to be looking at failover and kind of taking routes out, putting routes in, that kind of daily task, then you need to have a decent amount of resource behind you to cope with it.